this one, if you're opening this up and you're in Math 038 or 052, I'd recommend probably leaving this for now. This is very specifically things that you're going to see in Math 053. And also, if you're in the 02 level course, I'd say this is probably going to cause more confusion than help for you at this point. 052 students will need to do this in 053. So if you're feeling like you followed all the equation stuff pretty well so far, then maybe that might make sense for you. 038 students, you will not need to do anything remotely like this in your course. In 038, we tend to not fight through the fractions so much. In the 05 level courses, it is actually very important because of where you're going in future courses to be able to work those fractions out. And yeah, good. All right. So when an equation has fractions, if we were to try to just jump right in and do the stuff we've already learned, on the really, really simple ones, maybe just make sure you're all muted there. I think might not be. Yeah, thanks. On the really simple ones, that it might work okay, but as just with the slightest additions in complexity, the fraction work gets really, really complicated really, really quickly. So what we want to do instead is we want to use our good old equations superpower, that we can do anything we want to as long as we can do it to both sides, because it turns out there's something we can do that makes all of the fractions just completely go away. So yeah, there's a single step we can take that will make all the fractions go away. Now, before I say this, and I'm going to say this a few more times probably, remember in red there, this only works when you have an equation. Don't do this in other situations. So people are working on their fraction addition, and they happen to watch me teach this, how to get rid of fractions in equations. And then they're like, oh, hey, I can just make all the fractions go away. No, you can't. Not if you're just like adding two fractions. Like if you have 2/3 plus 3/4, you got to do a common denominator, work out the tops, add them together, put them all together, see if it reduces all the stuff that we've done so far. But if you have fractions in an equation, you can do something that makes them go away, as long as you do it to the other side. But if there is no other side to do it to, you can't do this. So only when you have equations. Okay, so here's the steps that we're going to follow, and when this is done, you can screenshot it. I'll also come back to it at the very end of the slideshow, or if you want, I can send you a picture of this slide. So the first thing we're going to do is we're going to look at all the fractions that are in the equation and figure out the lowest common denominator, as if we were going to add or subtract them, but we're not. So that's the lowest common multiple of all the denominators. Step 2, we are going to multiply both sides of the equation, because remember, we can do anything we want as long as we can do it to both sides, by that lowest common denominator. This is the magic step that will make all the fractions disappear. Why are we allowed to do it? Because we're going to do it to both sides of the equation, because there's an equation that has two sides, right? As opposed to, like I said, you're just doing some fraction adding or something. Next, that's going to give us some brackets to expand, potentially, if there's more than one term on either side. And then we're going to use our canceling to make all denominators equal to 1, which means dividing by 1 doesn't do anything, which means, in other words, all the denominators basically disappear for us. No more fractions left. That's why we chose the lowest common denominator, because that is enough to cancel all the bottoms. And then step 5, you will now have an equation that doesn't have fractions, which means you can just solve it using all the same stuff we've already done. So let's look at a few of these. Start simple. 1/5 x minus 2 equals 3/10. So let's follow those steps. This is one of those topics where you really have to, some students really struggle if they can't see 4 steps down the road what they're going to do. But sometimes in math, you just have to say, forget what I've already done, forget what I'm going to do, let's just do one step. Just do what I have to do right now. What is the first step? I need the lowest common multiple of 5 and 10, the lowest common denominator, in other words, of those fractions. So what is the smallest thing that both 5 and 10 go into? Well, they both go into 10, right? Since one of them goes into the other. So that's step number 1. Okay, we got that 10. What are we going to do with that 10? We are going to multiply both sides by it. Okay, what's going to happen when we do that? Don't stress about it. Don't think about that yet, right? There, I just did step 2. I multiplied both sides by 10. I didn't even do anything, right? I didn't do any work. I didn't reduce anything. I didn't expand anything. I just said, okay, step 2, there it is. 10 times the left side, 10 times the right side. Step 3, if there's any brackets to work out, then we expand them. So you see on the right, there's just a single thing there, right? So it's just going to be multiplied. But on the left, we do have a bracket for that 10 to multiply through. So we got a minus sign is going to stay a minus sign. We're going to have 10 times a fifth x, 10 times 2, with the minus sign in between them. And over on the right, like I said, we just have 10 times 3/10. There's no bracket to multiply through. There's step 3, right? Just expand the brackets. Don't think about what you did before. Don't think about what you might have to do next. Just expand those brackets. Now, wherever, so we're going to do canceling. Well, we're going to do canceling to eliminate all the denominators. Now, remember, wherever there's a fraction here, that 10 has to become a 10 over 1 so that we can do fraction work. But notice that when there isn't a fraction here in this term right there, I just left the 10 as a 10 because I don't have to do any canceling, right? So I make all of the 10s I made into 10 over 1, and now I go through one at a time, and if I did my job right, choosing the 10, all of the bottoms will cancel out. So there in the first one, 10 and 5 can both be divided by 5. 10 divided by 5 is 2. 5 divided by 5 is 1. And you notice that the denominators are all 1 now that we've canceled. Over in this one over here, 10 and 10 can both be divided by 10, leaving 1 and 1. And it looks like a big mess, but follow it through for one more step. Let's clean up the mess. What do we have here? On the bottom, we just have 1 times 1, which doesn't do anything when we're dividing by 1, so we're going to ignore it. On the top, we have 2 times 1 times x. That's 2x. This next piece here, we have 10 times 2, which is 20. No fraction works, so that's fine. Equals, and here again, the bottoms all became 1, so on the top, we just have 1 times 3 is 3. So it's a bit of a mess in the middle because with all the crossing out and everything, but you see what we do is by that one simple step of multiplying both sides by 10, I was able to make all the bottoms disappear. And you will get to the point where you can do this a little faster and with showing a little less work often. So step 5, now that we don't have fractions anymore, we solve as normal. So we have a subtracted 20 on the left. I'm going to make an added 20 on the right, as we've been doing, knowing in the back of our head that what we really just did is add 20 to both sides to make the 1 go away and appear on the other side. 3 plus 20 on the right is 23. 2x equals 23. Now we divide both sides by 2 to get the x by itself, and we get an answer of 23 over 2, or if they want a mixed number, 11.5. Okay, so we pick a number that will make all the fractions go away, and then we multiply by that number. Why are we allowed to do that? Because it's an equation, so we can do anything we want, multiply by 10, as long as we also do it to the other side, multiply by 10. And like I said, once you get good at this, you'll find that there's a few steps in there you can sort of skip through a little quicker. So here's another one. We have a couple fractions there, a couple pieces that don't have fractions. We want, as soon as you see an equation with fractions. You want to think, don't start moving the pieces around. Don't start adding this and dividing by that and subtracting those things, right? As soon as you see that, you say, I want to make the fractions go away. Otherwise, this is a monster question. So what is the lowest common multiple of the denominators, 6 and 9? Maybe you're getting good at your LCMs and you can just see that, or maybe you need to list the multiples. That's fine. List the multiples of 6, list the multiples of 9, and look for the first one that appears in both lists, which is in red there, 18. So 18 is the smallest thing that both 6 and 9 go into. Or use your times table sheet as another way and go across the 9 times table until you see something that's also in the 6 times table. All right, so we have identified the LCM is 18. So step 2, take that 18 and multiply both sides. This is actually the easiest step because you just write it like that, right? I'm going to multiply both sides by 18. Okay, I got brackets on both sides, so I'm going to need to expand those brackets. The 18 goes in on the left, so 18 times 5, and 18 times a 6th C with a plus sign in between them in green. On the right, a minus sign in blue with 18 times 2/9 and 18 times C on either side. Let's see what all this stuff looks like. 18 times 5, that's just a multiplication. We can do that. Oh yeah, so we're going to use our fraction canceling now. Back up. So, okay, I probably would have started to multiply things there, but okay, yeah, this makes sense. We're going to do our fraction canceling, which means wherever there's a fraction, that 18 has to become an 18 over 1. So 18 times 5, no fractions to cancel, just leave it. But here we got a fraction, so we got to make that 18 over 1. Here we have a fraction, got to make it 18 over 1. Here, no fractions, so just leave it. Okay, let's look at these two fraction pieces now, and if I did my job right, that 6 should go away completely to a 1, and that 9 should go away completely. Sure enough, 18 and 6 cancel because both can be divided by 6. 18 divided by 6 is 3, 6 divided by 6 is 1. And 18 and 9 can cancel to 2 over 1. You might notice that another way to think that through, because you know the bottom's always going to be 1, is you can just think, what's 18 divided by 6? 3. What's 18 divided by 9? 2, right? Might be an easier way for you to think that through. It works in this situation because you know for sure that you've set it up so the bottom will end up being 1. All right, clean up the mess. 18 times 5. Might have to go off to the side and work that out, but it turns out to be 90. In this piece here, 3 times 1 times C is just 3C. Because the bottom is 1, we don't bother to write it. Again, in this piece, the bottom is 1, so we're not going to bother to write it. The top is 2 times 2, 4. And then minus 18 times C, we just write as 18C. So there is the equation. This ugly thing with the 1/6 and the 2/9 now has become a nice simple equation with no fractions in it at all. So now we're just going to solve as normal. And I say to pause, if you're watching this video, you can pause and give that a try yourself. I think I'm just going to carry on for the sake of time here. So this is the kind that we were working on last week. We got variables on the left and variables on the right. I'm going to get all of my C pieces over to the left and all of my constant pieces over to the right, so that negative, that subtracted 18C on the right becomes an added 18C on the left. The added 90 on the left becomes a subtracted 90 on the right. Like so, and now I'm going to recolor because now that I've collected, so take a look, all of the C pieces are on one side, all of the not C pieces are on the other. Let's collect them together. 3C plus 18C is 21C. Plus 4 minus 90, so they're going in opposite directions, so subtract them and you get 86. Did we go further to the right? or the left. We went further to the left, so it's negative 86. And now all we got to do to get the c by itself is divide both sides by 21. And then a bit of fraction work. Negative 86 over 21 doesn't actually reduce. It looks like it might, but it doesn't. But if you want to write it as a mixed number, there should be a negative sign right there in front of that 4 that got missed on this. So that should be negative 4 and 2/21. Okay, so if you're feeling a little overwhelmed by these, that's not unusual. You really need to try some of them. But once you get the hang of it, making those fractions go away makes a huge difference. So here's one. I'm just going to say, see how far you can get. If you get stuck a couple steps in, don't worry about it. But there's the list of the steps. See how far you can go on this. And yeah, there we go. So, find that lowest common multiple if you can. Once you find the lowest common multiple, try multiplying both sides. If you get that far, see if you can expand the brackets and so on. And we'll take a little pause here so people in the class can try that on their own if they want to. Just see how far you can get on it. Let's go step by step. First, we need the lowest common multiple of all of the fractions, 6, 4, and 3. What's the smallest thing that all three of them go into? You might just be able to spot that one, but if not, let's list off the multiples of 3. 3, 6, 9, 12, 15, and so on. Okay, now multiples of 4. We can keep on going further if it turns out we need to. Multiples of 6, 6, 12, 18, 24, and so on. And then look for the first thing that appears in all three lists. It is 12. The lowest common multiple is 12. We're not going to try to find common denominators and add and subtract fractions. Instead, because this is an equation, and only because this is an equation, right? If this was just the left-hand side and not the right-hand side, no equal sign, you would have to do common denominators. But because this is an equation, I can do anything I want as long as I do it to both sides. So what am I going to do? I'm going to multiply both sides by 12, like so. Now we see we got brackets on both sides. So in order to make that 12 do its job, what is the job of the 12? It's going to make the 6, the 4, and the 3 on the bottom disappear, right? Because we chose it that way. In order for it to do that job, we have to expand the brackets. So 12 multiplies by both of the things in this bracket with a plus sign between them, like so. And 12 multiplies by both of the things in this bracket, also with a plus sign between them, a green plus sign in that case. So there's the brackets expanded. Now, wherever we need to cancel fractions, because remember, in the back of your mind, you remember that the whole reason you're doing this is because you can make all the fractions go away. Wherever we have fractions to cancel, that 12 becomes a 12 over 1. Wherever we don't have fractions to cancel, like this piece right here, the 12 just stays a 12. Okay, so now one at a time, we're going to do the canceling. 12 over 6 cancels to 2 over 1. 12 over 4 cancels to 3 over 1, because both divide by 4. And 12 over 3, both divide by 3, cancels to 4 over 1. 12 divided by 3 is 4, and 3 divided by 3 is 1. That's the messy step. Now let's clean up the mess and see what we got. In the first term, just 2 times 1, and as we expected, all the bottoms are gone. In the second term, all the bottoms are just 1. On the top, 3 times t, that's 9t, equals this one, just 12 times 1 is 12. And then plus, in the last one, 4 times t on the top, and as we purposely did, all the bottoms are 1. There we go. So we have made all the fractions go away, and so now we just take that equation we ended up with, 2 plus 9t equals 12 plus 4t, and we just solve that as normal. So I'm going to get all my t's to the left, so this added 4t over there, I'm going to make a subtracted 1 on the left, and the added 2 on the left, the constant, I'm going to make a subtracted 2 on the right, like so. Again, knowing that what I really just did is subtract 2 from both sides, makes that one disappear and that one appear. And subtract 4t from both sides, makes that one disappear and that one appear. Now I can group together 9t minus 4t is 5t on the left. On the right, 12 minus 2, 10. Divide both sides by 5 to get the t by itself. 10 divided by 5 is 2. So that's the basic strategy. Make all the fractions go away. And if you're thinking that looks really ugly and difficult, I'm not going to say it's not, because it can get quite complicated, but it's so much easier than what you would do if you were to try to solve this by actually leaving those as fractions and trying to do all of the fraction work all the way through. Okay, very last thing. We just claimed that t equals 2 makes the left side of this equation equal to the right side of this equation. Can that actually be the case? Does t equals 2 actually do that? Well, let's find out. This is some good practice for those of you that are still in the basic review unit, because here comes some fraction work and some order of operations, which is what you're doing in chapters 1 and 2. So we're going to take the left side of the equation and the right side of the equation. Notice when I separate these, I don't have equations anymore, do I? Right? So you can't just make all the fractions disappear. I can't go to the left side and say, oh, I'm going to multiply by 12 and make the fractions disappear. You can't. It's no longer an equation. We are now going to plug in a 2 for the t. So we're replacing the t with the 2. And we're going to actually do the fraction work to verify that our answer actually does work. So over on the left, if I want to multiply 3/4 times 2, then that 2 needs to be a fraction, 2 over 1. Now I could just multiply here if I want, or because I'm multiplying fractions, I notice that the 4 and the 2 reduce to 1 and 2. So that gives me a 6th plus 3 over 2. I want to add these fractions. In order to add fractions, I do need a common denominator, right? For multiplying, I don't need a common denominator. I just multiply the tops, multiply the bottoms. But to add, I do. So I notice that 2 times 3 is 6. So if I multiply the top and bottom of that fraction by 3, I will have created a common denominator of 6. So I have 3 times 3 on the top is 9, 2 times 3 on the bottom is 6. 1/6 plus 9/6. When I add, the denominator stays the same, and you add the tops. So 1 plus 9 is 10. And whenever I get to a final answer, I check to see if it reduces. It does, because those are both even. Divide the top and bottom by 2, and you get 5 over 3. Okay, so there was some fraction work, right? That's the kind of stuff we would have had to do all the way through the solving if we had not been able to make the fractions go away. And again, so you see that this is an expression now, right? Just the left side by itself is an expression, not an equation. You can't use our equation superpower and do whatever you want. You have to actually follow through the steps and work out the answer. Let's look over at the right side. I replace the t with the 2. This one's going to be a bit easier. So I have 1 plus 2/3. If I want to add those, that 1 needs to become a fraction, 1 over 1. And I need a common denominator, so I notice that 1 times 3 will give me a common denominator of 3 in both fractions. So I do top and bottom by 3. So that gives me that 1 has turned into a 3 over 3, right? And the 2/3 so far has just sat there and stayed 2/3. Now when I add these fractions, the bottom stays the same. I add the tops, and look at that. T equals 2 does indeed make the left side and the right side of this equation both equal to the same thing that thing happens to be 5/3, which, by the way, I don't know if you've noticed, but what the variable makes the left and the right side equal to is really irrelevant. All that matters is it makes them both the same, right? T equals 2 is the important thing here. That's the answer. That's the value that makes the equation true.